This is the solution to example 6 from notes 1.6. Now that we know how to simplify square roots of negative numbers using the imaginary number I, we can now solve quadratic equations that have imaginary solutions. So let's try these three examples. So for the first one, x squared plus 4 equals 0. I'd like to solve that by extracting square roots. So I would move the 4 to the other side, take the square root of both sides, and now we'll say x is equal to plus or minus the square root of negative 4. But the square root of negative 4, I'll pull that negative out and write it as I, and the square root of 4 is 2, and then usually we would write that as plus or minus 2i. So this has two imaginary solutions. The next one you could either solve by quadratic formula or completing the square. You can't factor. Let's complete the square on this problem. So to complete the square, I'm going to move the 3 to the other side of the equation. Then I want to add b over 2 squared, where b is the number 2. So I'm going to do 2 over 2 squared, which is 1. So that's the number that I'm going to add to both sides of my equation. The reason for doing that is now we can write the left side of the equation as a square of a binomial, because it's a perfect square trinomial. That is x plus 1 quantity squared. And negative 3 plus 1 is negative 2. So x plus 1 squared is equal to negative 2. We'll take the square root of both sides, and then we'll have x plus 1 equals plus or minus the square root of negative 2. So x plus 1 equals plus or minus, instead of the square root of negative 2, we're going to write that as I rad 2, and then subtract 1 from both sides, so x equals plus or minus I rad 2. Those are our two solutions. The last example, let's solve this one by using quadratic formula. It's not going to factor. I don't want to complete the square when the leading coefficient isn't 1. So we'll have quadratic formula. We have a is 2, b is 5, and c is 7. So x is equal to negative b, negative 5, plus or minus the square root of b squared, which is 5 squared, minus 4 times a, which is 2, times c, which is 7, all over 2 times a, which is 2 times 2. So we have negative 5 plus or minus the square root of 25 minus 4 times 2 is 8 times 7 is 56 all over 4. So x is equal to negative 5 plus or minus the square root of 25 minus 56 is negative 31 all over 4. So x equals negative 5 plus or minus the square root of negative 31, we're going to write as I rad 31 all over 4. And now we're going to write those in standard form, complex numbers. So we'll put the real part, negative 5/4, plus or minus I rad 31 over 4. So if we were to graph the function y equals 2x squared plus 5x plus 7, which is the equation we just solved, and we wanted to know how many x-intercepts it would have, that's solving the equation 2x squared plus 5x plus 7, and we got these two imaginary solutions, which means that this graph, if we were to graph it, would have no x-intercepts, because there are no real solutions. If there are no real solutions, there are no x-intercepts.